Morning class. Today I am going to start a video series on experiments based on circuits. In practical exam you are supposed to attempt two questions. One which is based on optics and you have to perform experiment with help of lenses, and the second in which you have to perform experiment with circuits. So I'm going to explain you about every circuit component, its working, its structure, how to take reading from that component, how to connect circuit, and during that explanation I'll also perform an experiment to verify Ohm's law. So this class is going to be a fun. We will have interesting discussions. So I'm going to focus my camera on the electrical components. You get ready with your copy and pen, and let me start our class. So let me focus my camera on the circuit components, and now I am going to introduce you with the circuit components. See, the very first component is this battery eliminator. This battery eliminator is a device which bypasses the requirement of the battery and it gives us voltage of desired value. We'll get introduced with this battery eliminator. In the meantime, I explain you all the components. This is resistance box. It provides variable resistance in the circuit. Then we have an ammeter. You know that this is used to measure current in the circuit. And then we have a voltmeter. This is used to measure potential difference between the 2 points of the circuit. And we are having this resistance which is made of constantan, and this resistance wire has some specific properties. I'll explain you about each component, and I am starting my explanation with this magical instrument resistance box. Why I'm saying magical? You will get convinced that yes, it's a beautiful arrangement. Can you see better the copper metal strip here? This copper, you know, is a very good conductor and it provides very small resistance in the path of the current. Now just look at these knobs. These knobs are also made of copper. These knobs are also made of copper. And then look at the air gaps between the metal strips. Let me remove all the knobs. Look at the gaps between the metal strips. Now why these gaps are made here, that will come to know when we open this resistance box. And we have the structure inside the resistance box. Beta, can you see the coiled resistances? These coiled resistances are of different length. See? This resistance has least length. Then we have all the coils of different resistances, lengths. And the second point which you should observe, all these resistances are connected in series. Just look at the connection they are having. They are connected in series. Can you see their connection, their series connection? Can you see? These are connected in series. Getting clear? So all these resistances are connected in series with each other, but they are connected with the air gaps in parallel. Just look at the air gaps. This is air gap, and see how this air gap is connected with the coil. This coil is connected, in parallel to this air gap. Just look at the connection. Similarly, this coil is connected in parallel to this air gap. Now look at this next coil. This is connected in parallel to this gap. Similarly, these two coils are also connected with their gaps in parallel. This gap, which is 5 ohm, connected with this coil, 5 ohm coil parallel में, and 10 ohm coil in parallel with this gap where 10 ohm is marked. Now interesting thing is this gap where it is written infinite. Now look at the structure here. Can you see there is no coil at all? Between these two screws there is circuit broken. Thus, this broken circuit provides infinite resistance in the path of the current, and this broken circuit is in parallel with this gap where it is written infinite. So let me understand now how this resistance box provides variable resistance in the circuit. This is diagram of resistance box. You have just seen this diagram in reality. Now we will understand that how this resistance box works. You know that resistance box provides variable resistance to the circuit. Now I have shown you that resistance box has metal strips and the air gaps, right? Now if all the gaps are filled, with knobs tightly, pay attention, all the gaps are filled tightly. Then current enters through this screw and passes through this copper strip, because copper offers it low resistance path and current safely exits through the second screw. But if I remove this knob, for example, if I remove this knob and say here it is written on the resistance box 1 ohm. Now what will happen? The current will enter through this copper strip, but circuit is broken here because there is no knob and air gap is in between these two copper strips. So current does not have any option but to pass through this coil current move to this point through this coil only. And after that you can see that copper strip is again available, that is low resistance path is again available. So current will pass through this screw. So removing the knob and creating air gap, actually we are including the resistance parallel to the gap into the circuit. That is why it is written always that take out 1 ohm resistance knob. When you take out the knob, then that resistance includes in the circuit, is included in the circuit. This is the way this resistance box works. Now whichever knob you will remove, that resistance will be included in the circuit. Very well. Now here 2-3 very important points you should know. So let me explain you, and I have written it in a proper language also, so that if you are getting any question related with this concept, you are able to answer it in proper language. Look at the way the coils are folded. They are double folded, beta. See, this coil is moving like this and then it is folded on itself. Coil is, this resistance wire is in the form of coil because we want to accommodate the length of the resistance wire in a small space. But in that process, the wire takes the shape of the coil. Now in the coming lectures, you will study the electromagnetic induction concept, although you have studied it in 10th also, that if a current flowing through the coil changes, the magnetic field produced by the current also changes. Thus, variable magnetic field and variable magnetic flux associates with the coil. And this variable magnetic flux, or you can say when flux associated with the coil changes, an EMF is induced in this coil which will oppose the change or which will oppose the flow of the current here. So instead of only having resistance of the resistance wire, we will have an inductive resistance introduced, which is undesired. We want a 1 ohm resistance here only because we have designed our experiment for that resistance only, but an unwanted inductive resistance comes into the picture. So these coils are always double folded. Why? Just look at the 2 coils, adjacent coils, and pay attention in their direction of their currents. In this coil, current is flowing from right to left. Can you see? And adjacent coil is having current towards, just opposite, towards right. So the field produced by this coil is exactly cancelled by the field produced by this coil. They are having opposite currents. So when net field associated with this coil is 0, then obviously net flux associated with this coil will be 0. So when you switch on the current, during that time when current is establishing in the circuit from 0 to value I, or when you switch off the current, when current is going down from value I to 0, during that time when current is varying, the flux associated with the coil is 0 because of this special arrangement. So flux associated with the coil is 0, so there is no induced EMF and we just have the coil resistance only. So this is why the resistance coil in the resistance box is double folded. This is an important concept which I have to explain you. Now the next concept which I have to explain you is that when this knob is, I explained you actually, but if this question is there, then how to write the answer in a proper language. So just look at the proper explanation and proper language. When copper plug is provided in the gap, then current has low resistance path through the copper strip and it flows easily. But when any knob is taken out, the air space provides infinite resistance in the path of current. This current then has only way to flow through the resistance coil. Thus, that particular resistance is included in the circuit. Then the next point, just looking at these points and the proper explanation, you can answer any question related with this concept in your board paper. Next point is before starting experiment. This is very important point for your experiment also. I am again and again telling children that please tighten the knob. Before starting experiment, all knobs are made tight. If any knob is loose in its gap, an air gap will be there between the strips, and which will introduce that particular resistance unknowingly. You don't know that particular resistance, and maybe that resistance is the infinite resistance. That resistance unknowingly, and it will be included in the circuit, that resistance, and will lead to the wrong result. So what is the conclusion? That before starting your experiment, all knobs are made tight. Got it, beta? The next point which I have to mention is that due to inductive resistance induction, we double fold the each and every resistance coil. I explained you, but I am giving you the proper language so that if there is any question, then you can answer that question in the correct technical language. Children, I always try to prepare you for your board question paper also. And these experiments, concept related with these experiments, all are included in your board syllabus. I think you can pause the video and you can write the proper language. Clear? So today we got the concept of resistance box, its structure, its working, and the questions which are probable to be asked in your question paper of board, as well as any of this question can appear in mains or NEET. So today, this is for your first lecture of ISC Physics Practical related with the circuit experiment. Give me your feedback if you are getting the concept of resistance box, or you can press the like button. And if you are having any doubt, be free to ask me in the comment section. Now in the next class, I am going to explain you about battery eliminator.